Good morning, everybody. This question's about a plumber. Now, a lot of people think I'm a plumber because I carry this toolbox around with me. Well, I'm not a plumber, I'm a maths teacher. The reason I carry this toolbox around with me is because it's got equipment in it to help you do your maths, such as pens and protractors, rulers, kitchen sink, green pens as well. Anyway, enough of that. Let's get back to this question here. The topic we're going to look at this morning is about interpreting correlation graphs. Now, if you see this graph that's been drawn out here, there are a few things that we've got to find out from this graph, or possibly about the graph as well. First thing I've got to find out is, for A, is the cost the plumber charges for 2 hours work. So if we look at our hours here, there's 2, we go up, we go to the cross here, mark that there, 100, we can read across, so we'll put a little A there. Let's get a better red pen here. So £150, if you can see, up from 2 across 150, would be the cost the plumber would charge for 2 hours work. Now, B, they're asking for something called the line of best fit. Now, what you do for the line of best fit is you grab the ruler, which was too big to go in the toolbox, and you've got to try and get a line, or make a line, it's not going to be exact all the time, which is well in amongst all the crosses here, and it's got a reasonably even amount of crosses running either side of it. So, we get our line there, and if I'm sort of drawing a line there, that wouldn't be a line of best fit because it's got all these crosses up here. So we're sort of gradually looking, I'd say, down a bit. Something like that could do the job. Now, this line of best fit hasn't got to be exact, it's got to be amongst the crosses, and so you've got a reasonable amount of crosses either side of it. Some of the crosses might even lie under the line. So that would be our line of best fit. Then C, they're asking us to look at something called an anomalous result. Now, an anomalous result is actually something that is way off the beaten track. It's nowhere near any of the other crosses. Can you see where it is? Well done. It's there. That's the anomalous result. So it's something that doesn't actually fit the trend of these crosses. So we're now looking for the cost for 3.5 hours work. So now what we've got to do, if we've got any questions after we've been asked to draw our line of best fit, we now use that line of best fit to work out these questions. So we've got 3.5 hours here, so we'll go up from 3.5, and then we can go across then to here. Now, if you notice, between 150 and 180 there are 5 squares. That means 180 to 150 is 30. That means every square is worth 6. So that will be about 174. So that would be our D then, £174. How long would the plumber charge for £120 worth of work? So this time we'll go back the other way, £120, and then we go down to there, and it's just over an hour. I'd say that'd be about an hour of 5 minutes or something like that. So you could say 1 hour, 5 minutes. Finally, why have we not got a reading for 300 hours? There's 2 reasons here. One, the graph only goes up to 5, so you can't really use this line to go all the way up and sort of measure axis for 300 hours. And the other thing is, Mr. Hughes is just a small domestic plumber. You might want to put the excuse in like that. The sort of jobs he does only last a day or 2 at the most. 300 hours would probably be a bigger job, and there might be a different charging structure. So in other words, this graph wouldn't be appropriate for jobs of a much larger scale. The final thing they might ask is what type of correlation is it? Now, we've done this before. The type is it's going uphill like that. That's indicating something called positive correlation. So there we have it, a few things there to describe how you can read and use information once you've got a correlation graph.